training on the spatial equity data tool. I'm Kristen Brown, and on behalf of your group learning team at the Urban Institute, thank you for being with us today. Today's event is the second installment of our Social Determinants of Health series, which will occur on the third Wednesday of every month this year. Today, we're going to learn about analyzing geographic inequities. The neighborhood environment is an important social determinant of health, and where you live can affect access to health promoting resources such as healthy food, opportunities for physical activity, or even the ease of getting vaccinated. And knowing where these resources are and are not is important for developing equity-centered programming efforts. Before we go further, I'm going to do our typical brief review of features and requests for this meeting. Please remain on mute unless you are speaking, which we welcome you to do during the Q&A portion so that we can avoid accidental disruptions. I encourage you to introduce yourself using the chat feature now and tell us where you're zooming in from. You should also use the chat feature to send us any questions you have. We've allotted some time near the end of the hour for the Q&A, but I encourage you to chat your questions as they come, since we may be able to incorporate them earlier. The slides and recordings from this session will be available after the fact on our paid learning community website, as well as circulated through the CDC's Adult Vax Program listserv. And finally, if you have any technical difficulties, we want to know about them. So please send us a note to our group learning manager inbox, which is vaxequitylearning@urban.org. And now I'd like to introduce today's speakers. First, we have Alina Stern, who is an Associate Director of Data Science at the Urban Institute, studying policy solutions to advance equity and inclusion. Before joining Urban, she worked at Aid Data, the Sunlight Foundation, and the Center for Data Science and Public Policy, where she used data science methods and tools to inform and design of government policies and international development programs. Joining her, we have Gabe Morrison. Gabe Morrison is a data scientist at the Urban Institute. He conducts research and builds tools to address equity-related issues in cities and counties, often with spatial data. Gabe has also worked at the Cook County Assessor's Office, the University of Chicago Center for Spatial Data Science, the Brookings Institution, and Metropolitan Planning Council. So I will now hand it over to Alina and Gabe.
Great. Thanks so much, Kristen. And thanks so much, everyone, for being here today and making time for us in your schedule. We're really excited today to be talking to you about the Spatial Equity Data Tool, which is a free-to-use data tool that is created by the Urban Institute and that we think could offer some relevance for the types of questions that we understand you all are asking. And then throughout, we'll sort of share the tool and introduce it. And we also have time for some discussion sections because we want to hear from you of sort of how you potentially envision that you might use this tool in your own work, as well as if there are challenges or obstacles that you anticipate and sort of additional supports from the Urban Institute that would help you to use this tool. And that input will be really helpful to us as we're continuing to design the sort of resources and supports that we offer to users of the tool. Next slide. So why are we talking about an equity tool? I don't think I need to tell folks in the Partnership for Vaccine Equity this, but as you all know, many organizations are making commitments to center equity in policy and program decisions, but there aren't standardized definitions of what equity means and how to measure it. And so the result is that without sort of clear definitions and clear tools for equity analysis, it can be really time and resource intensive for organizations to do these types of analyses in order to uphold those commitments, and in some cases, prohibitively so. Next slide. And so that's why we created the Spatial Equity Data Tool to create a free open source resource that organizations can use to help provide some of those sort of standardized definitions of equity, as well as an easy to use tool to help folks incorporate equity analysis into their own work. Next slide. So at a very high level, the way the Spatial Equity Data Tool works is that users, users can upload their own data that have latitudes and longitudes. This basically is data that reflects any sort of resource or opportunity that can be sort of mapped on a map. So that could be the locations of vaccine clinics, or later Gabe will show you an example of COVID-19 testing sites. You could also think about, community outreach clinic locations, or, the location of other sort of social determinants of health, of playgrounds and green space. Or you could even think also about negative utilities like the sites of pollutions or green fields. So you upload your own data into the tool, and as long as it has that sort of latitude and longitude, that point on a map, the tool can analyze the data, and then it automatically performs some analyses for you and then gives you back a dashboard that has two key pieces of information. The first is what we call a demographic disparity score. So this answers the question sort of which communities and demographic groups have more or less access to this resource sort of relative to their share of the population. And this looks across sort of the whole area you're interested in, so the whole city or county or state. The second piece is the geographic disparity score. And this answers the question of which neighborhoods have more or less access to the given resource relative to their population size. And so that looks at, we sort of approximate neighborhoods using census tracts, and it sort of visually shows you which neighborhoods are over or underrepresented in access to the resource of consideration. Next slide. So how can you use this tool? We think that using the spatial equity tool makes these sort of equity analyses much easier. Next slide. So one way this happens is you can compare data from across time. So for example, if you were working on a vaccination campaign that was spanning years, you could easily run data from year over year into the tool and sort of understand how your organization is making progress towards its equity goals over time. Next. You can also compare across geography. So if you work in a multi-county area and you want to understand how different counties compare to one another in terms of equity and access to different resources, in a very standardized way, you can compare across different geographies all using the same tool. Next slide. And then you can also compare across programs. So one thing we think is really compelling about the tool is it provides a sort of standardized framework for thinking about equity in the distribution of resources that can apply across programs. So if you want to, compare, again, when you're thinking about the social determinants of health, if you want to look across those different determinants and think about sort of equity in distribution, you can do that with this one tool. Next slide. And bottom line is the tool is free to use. We think it can save time on performing data analyses and is reproducible. So everything is really transparent and open source, and you can return to the tool and rerun your analyses as many times as you need. Next slide. So how do we think folks can use the tool? One way is measuring equity in the allocation of place-based programs. So for example, the locations of vaccine clinics and looking at the sort of communities served by those different programs. Another way to use the tool is actually looking at representativeness in the participants of programs. So if you had, let's say, address information on folks who are participating in a program that your organization runs, and you want to know if those participants are representative of the community you're serving as a whole, or representative of a specific sort of target population in that community, you could upload that data into the tool and perform that analysis. The tool is also really useful for targeting a future investment. So, identifying those neighborhoods or communities that are currently underserved by the sort of present distribution of a resource can help your organization identify and prioritize neighborhoods for future investment. And then, as we mentioned a couple slides ago, you can sort of compare over time to analyze your progress towards equity goals over time. Next slide. So how have folks actually used this tool in practice? A nonprofit in Marin County used the tool to analyze disparities in the locations of childcare center locations to sort of understand equity and access to childcare. Residents in the city of Chicago looked at equity in building permit approvals across the city. The Bloomington Pedestrian and Bicycle Safety Commission used the tool to analyze equity in sidewalk funding allocations. So it's another type of data of looking at the sort of locations where money is being spent and thinking about sort of distribution and budgetary allocations. And then finally, the City of Los Angeles Department of Street Lighting used the tool to allocate funding for new electric vehicle charging stations. Next slide. And these are just a couple of examples. You can really get creative with how folks are using the tool. And I think this example is illustrative of that. A couple of years back, industrious Twitter user reverse engineered McDonald's API and basically to ping their ordering system to figure out which locations have broken ice cream machines. Apparently for McDonald's fans, it's a common grievance that, you know, you go there excited to get your ice cream and then the ice cream machine is broken. So he was able to create this, you know, very timely spatial data set of, you know, which McDonald's locations have broken ice cream machines. Next slide. And then a different Twitter user just plugged that data into our tool. And they found, interestingly, that while white neighborhoods are overrepresented with McDonald's locations, the sort of locations with broken ice cream machines are disproportionately located in Black and low-income neighborhoods. And so while, of course, McDonald's ice cream is not the most perhaps not even the most relevant example to you all, and certainly not how we imagine the tool being used. We bring this up to show that really sort of like your creativity is the limit in thinking about how this tool could be used in some of these sort of really interesting and perhaps unexpected applications. And so in the discussion section, we'd love to get really creative with you all and brainstorm some applications that are relevant to the work that each of your organizations is doing. Next slide. So with that, I will turn it over to Gabe to actually do a live demo to show you how the tool works in action.
All right. Hi, everybody. Thank you so much for having me here. I am going to stop my screen share, and I will kind of just, as Elena just said, walk you through kind of the end-to-end process of kind of acquiring data and then plugging it into the tool so you can kind of get a feel for what that'll look like. So here we go. We're stopping share, testing my Zoom capabilities. And I'm just going to share my entire screen, so we gotta exit out of here. Okay, excellent. Okay, so the example data set that we'll be showing is from the city of Washington, D.C., which is where we're located. And we're going to look at COVID testing locations. And so we're just going to go to their open data portal, which you can get to by just typing DC open data portal. And then it's this open data DC. And then it's this, you know, great website that, you know, it has all the data you would ever want to use. Then you can search, getting a little lost in Zoom here, but let's see. So you can search COVID testing. Or maybe it's up here. Let's try that again. COVID, you can see I've done this before. COVID testing, excellent. So this is their data portal. You can see there's this DC COVID testing sites data set, you know, last updated in January 2023. So this is great, you know, and it's free. So we just opening it up bigger. Here we go. We can scroll down, we can see, and then they have these different data sets, but we're going to choose this DC COVID testing locations. And then here's what it gives. This is this nice dashboard that they have online, and it can show you the boundaries of DC are kind of this, these dotted lines. And then it shows you these points that are the locations of these COVID testing facilities. So then we can just come over here and click download and download as a CSV or a comma separated value file. And we're just gonna click download, generate a new downloaded file. Okay, it's thinking about it. Okay, great. You can see it downloaded. I will, for ease of access, just drag and drop this onto my, okay, replace. Excellent. So we have this file. Now you can see it on my screen. So we have now kind of just done this first step, which is, you know, download the data to our machine so we're ready to go. So the next thing is you can actually go to our spatial equity tool. You can go here. If you just search spatial equity tool, excitingly, Urban Institute is the first link, which is great. So you can just click on it. And this opens up our website. So there's a lot of different options that you can choose from, and I'm happy to talk about them. But as kind of Elena mentioned, you have 4 different options for different geographic scales at which you want to analyze the data. So obviously this is DC. DC is a city. So we're going to click on the city level data, and then we're going to upload our own data. I would note we're not going to show this, but if you go onto this website and just want to get a flavor for some of the analyses you can run, clicking on these and then clicking use sample data gives you a great opportunity. So just showing for city level data, we have 3 different examples uploaded: Wi-Fi hotspots in New York, 311 requests in New Orleans, bike share stations in Minneapolis. But we'll just go back. Great. Upload city level data, upload our own data. And then all you have to do is just drag and drop the file in here. So you'll note there's a couple specifications here. Your CSV file must have unique column headers. So we didn't really investigate this, but most data sets should have that, but just be aware. You also need to have, this is like the key requirement that we'll talk about. You have to have columns that correspond to longitude and latitude in your data set. So that's really important. And then lastly, your file can't be really big. If it's larger than 2 gig, the tool will not handle it. So those are some caveats that you can see, but it looks like we get these check marks. It's all good. Then hopefully the tool has kind of taken a guess at what our columns are for longitude and latitude. Also, if you have data that says longitude or longe, it'll guess there. The one other thing I want to show you before we click run analysis are these advanced options. So there's two kind of advanced options that are here. There's filtering data and weighting the data. So we're not gonna do either of those for this demo, but I'm gonna come back to those and talk a little bit about what that could look like. But we're gonna click run analysis. Then it says, hey, we're uploading, we're analyzing the data, and it just thinks about it. And exciting drum roll, here we go. Okay, great. So here's what it says. So as Elena said, we get the demographic and spatial disparities. Also note the tool, we didn't tell this to the tool, we didn't say it was DC, but the tool has identified this data as in DC. So that's, good to know. So the demographic distribution and disparity scores are on top and the geographic disparity scores are on bottom. I personally think maybe the geographic disparity scores are a little bit easier to think about or see. So we're going to actually scroll down and start here. So I'll just close this out and make my screen a little bit bigger. Okay, so what we see here is a map of DC. So it found where our data is from. And we see these this range from dark blue to dark orange, with the dark blue showing over-representation of the data and the orange showing under-representation relative to the data. So more specifically, what this is saying is we're comparing the distribution of the points in our data set to a specific population. So right now we're comparing the total population, and you can move your mouse on different census tracts on the map, and it'll give you a really specific description of what's going on here. So you can look here, it says, hey, in the census tract, I'm looking over on the left, 23.02 in Washington, DC, we have 3.1% of our data points, but only 0.2% of the population. So we just take a simple, subtraction, 3.1 minus 0.02, or 0.2, excuse me, and that's 2.9. And so then we calculate, hey, this census tract is overrepresented by this 2.9. And we have the write-up, this neighborhood is 2.9% more of the data points than we'd expect if the data were distributed in accordance with your baseline. So it's very specific. So notably also so that's an example of overrepresentation. You can also have underrepresentation. So you can see a lot of these light orange counties are slightly underrepresented, which means they don't have what it's showing on the left is they have no data points. So there's not one of these testing facilities in their boundaries. And then also, we have here where there's no difference. And obviously that's because these regions are not where people live. This is a river and an island. So that is kind of a first glance read of this. A couple interesting points or things I want to note. For example, so we're making this comparison of COVID DC testing locations, and we're comparing those points to the total population. but perhaps we're concerned not about the relative distribution of this resource to the total population, but to a specific subgroup. So maybe, you know, as policymakers or in the nonprofit space, we're particularly concerned with, in this case, potentially people over 65, because, you know, they're more susceptible to really, you know, damaging cases of COVID-19 based on, you know, scientific research. So here in this little drop down, we have the opportunity to compare total population, but we can also compare these other breakout groups. Like, so for example, this is what I was saying, we can compare to senior population whose ages are at or above age 65. And then it runs kind of the same comparison, but just not with the total population, but with the population age 65. And again, it shows you the same kind of logic of, hey, you know, this census tract 13.02 in Northwest DC, it has 0 data points, no COVID testing facilities, but 1.7% of the senior population. So there's this difference in representation that we calculate. So that the one other thing I want to show you on this geographic disparity score is this data comparison option. So what this does is it has this really cool slider. So if we just look at our data, this shows, this shows our distribution. It just plots where people, for in this case seniors, live, you know, and we get the percent here, the percent of baseline. I apologize, this is our data, excuse me. This is where the COVID testing clinics, this is the spatial data we uploaded. If we scroll here, this is the senior population, and this is, you know, not that surprising. There's, you know, relatively even distribution of seniors across the city with potentially a little bit of overrepresentation on the far northwest side. Whereas here you see, because there's only, I think, 66 COVID testing locations, there are a lot more kind of hit or miss. One other thing I wanted to point out about the map, and we're just going to go back to the disparity score really quick, is you'll note one of these strong blue locations is here, and just zooming in, you can get some contextual features. So like, for example, in this space, there are a series of hospitals right here. So as you can see from the zoom in on the map. So perhaps it's not surprising that there's lots of COVID testing clinics in this census tract, given that there's a number of medical facilities here. So that's a helpful feature. You know, the zoom in on the map can show you a little bit of this neighborhood regional context. Okay, so that is the geographic disparity score kind of part of the tool. So that's one. I'm gonna just check. I see a note in the chat. Let me see. Or maybe, you know, maybe I'll show you the second set, and then we'll open it up to questions on the whole part of the presentation. But I'm definitely excited to answer, and I'm sure Elaine is excited to answer all the questions about this tool. So now we have, this is the second kind of set of things that the tool shows. This is the demographic distribution of our data. And again, we have an opportunity to choose our comparison group. But kind of what, as Elena mentioned at the start, what this is thinking is saying, hey, across the city as a whole, how do the census tracts look that have our data sets compared to the city? And so if that's a little unintuitive, you can like move your mouse over, and you can, this gives you a great interpretation of exactly what you should read from this chart. So you can say, hey, among Black non-Latinx residents, what we know is this: across Washington, DC, your data comes from neighborhoods that on average have 4.8% more residents in this demographic group than the city as a whole. Okay, so that's interesting. And we can see, you know, among the total population, you can see these groups are potentially slightly overrepresented in the data. Then down here, white non-Latinx residents, Latinx residents are potentially underrepresented by a few percentage points. There's also, as I mentioned, there's this drop down where we can say, hey, instead of counting all the people in the groups in this table below, what we can do is count the people in the groups below, but only among these subpopulations. So for example, we can look at population with extremely low income, and there's a really interesting finding here. So among populations with extremely low incomes, you can see there's a change in kind of the over and under representation. So for example, now we see a relatively large overrepresentation of white residents. And again, you can use this interpretation, on average from our data comes from neighborhoods that have 10% more residents with extremely low incomes from this demographic group than the whole city. So there's this change. And then also, at the very bottom, Black residents become underrepresented when we're only comparing among the people with extremely low incomes. So that's an interesting finding, and also one of the useful features of this tool where we can use these drop downs as opposed to just comparing total population. Okay, so those are kind of the key kind of parts of the tool. We want to stop here and kind of open it up for questions, and maybe I'll read more thoroughly these questions in the chat as well. Guarantees past report data be able to import from the central data.
And Gabe, I'll say I tried to answer his question in the chat, but let me know if I did not directly speak to your question. If you want to ask a follow-up, we'd be happy to answer it.
Resubmitted.
Oh, I see. Let's talk more. I think I will admit I'm not super familiar with this database that Urban is running. But yeah, we could definitely talk about opportunities to more directly import that data into the spatial equity tool, or how to make that as easy as possible, since this database lives at Urban, so that you don't have to sort of import the data again yourselves.
Great, thank you, Elena. Yes, okay. So I am going to stop sharing my screen and shift back to the slides then, and we'll go from there. Okay. Share screen. Okay. Excellent. Okay.
Awesome. Thanks, Gabe. So jumping back into, Gabe showed you a lot of the functionality of the tool, but of course, like any tool, it has a number of limitations that are important to be aware of. So the first and most important is that it can't tell you why certain areas or groups are over or underrepresented. And I'll actually extend a little bit more, and that it can't tell you whether over or underrepresentation is a good or bad thing. So for example, in that first demographic chart that Gabe showed, or maybe even let's talk about the geographic chart, he zoomed in on that one tract where there was really overrepresented, but there are a lot of hospitals there. Well, maybe that's actually a good thing that there's a particular concentration of COVID testing sites in that tract, because folks who are going to get healthcare at these different clinics can get a COVID test while they're there, or they perhaps have the infrastructure to provide COVID testing. So that might be a case where overrepresentation is actually a good thing, because it enables providing services more easily. Or similarly with the demographic chart, in that first view where we were looking at total population, we saw that Black and low-income residents were overrepresented in access to COVID testing sites. We also know those groups were overrepresented in terms of the impact of COVID on those communities, in terms of COVID cases and fatalities and just overall COVID impact. So maybe that's a good thing, that we'd want to concentrate COVID testing sites in these communities that bore disproportionate impact of the pandemic. So I think that's really where sort of the context and expertise that you all bring to the table is so critical in sort of understanding and interpreting these results and thinking about what action is important to be taken based off of them. The other limitation I'll mention is it offers a pretty simplified measure of access to resources. So right now, what the tool does is it looks at the census tract where, let's say, a COVID testing location is based, and then looks at the population in that tract. But that is, kind of simplified way of thinking about the population that has access to a given resource. So if I live on the border of one tract, maybe my closest testing site is actually in the census tract or neighborhood next door because I live on the border between two neighborhoods. And that's not really reflected in the tool currently. So we'll talk a little bit later about potential extensions of the tool that we are thinking about. And one of those is to sort of bring in some more sophisticated ways of thinking about access to resources that we think could sort of capture how people actually access resources across neighborhood bounds. The next limitation is that it only allows for national, state, county, or city level data sets. So for example, if your organization's area of coverage is a metropolitan area, which is many counties together, right now the tool couldn't do like metro area analyses, or if you're only working in part of a city, by default, the tool will look at the whole city. So again, that's something that, we would like to do in the future, is allow a bit more custom geographies. That's a limitation to be aware of. The other limitation is that the city level analyses, are limited to cities that have a population of more than 50,000 people. So for particularly rural areas or small cities with populations below that threshold, they would not be captured in the tool currently. And then finally, Gabe showed through his example the importance of thinking about a good baseline data set. So for example, when he switched from total population to low income population, we saw how that demographic chart really changed and the results were quite different. And so, the key question to ask yourself when thinking about the baselines is like, well, who is the target population for this resource that we're looking at? And so, for example, if we're thinking about COVID testing sites, maybe the sort of better baseline would be the distribution of COVID cases throughout the city. If we'd want to be really targeting COVID testing sites to areas and communities that had a higher incidence of COVID. And that, of course, is not one of the built-in baseline data sets. So you might not be able to have sort of that perfect match in all settings. I will preview that this is coming soon. We'll have some tools that actually address this point, and we'll sort of be giving users the ability to incorporate some of their own sort of custom baselines or custom demographic data sets, so you can sort of more precisely tailor the tool to a given use case. Next slide. So, to basically summarize sort of what can the spatial equity data tool do, compared to a population distribution in a geography, it can tell you if certain neighborhoods and demographic groups are over or underrepresented in your data, how those disparities compare across time, geographies, or across different data sets or program areas. And it can tell you whether those results are statistically significant. So Gabe called out that gray area on the map, and that was an area where we didn't have sort of a statistically significant difference. So we sort of bring in that testing to say, hey, how, for a disparity of a given size, do we think it's sort of a statistically significant disparity? Next slide. But sort of extending on those limitations or number of questions the tool can't answer. Again, it can tell you why certain areas or demographic groups are over or underrepresented. It also can tell you if the quality of data is equal across your geography. So for example, not all COVID testing sites are made equal. Some maybe have really long lines because they're highly in demand, or others might not have accessibility or language translation assistance for certain communities. And so some of those elements of quality might not necessarily be reflected in this analysis. The one caveat I will add is Gabe mentioned that weighting advanced feature in the tool. And so that does give you the ability to incorporate some measures of quality in there that can be quantified. So for example, if you had a column that said like the number of people performing tests at each clinic, or the sort of capacity of the testing clinic, you could give clinics that offer sort of more folks who can do tests simultaneously greater weight in the analysis than smaller clinics. So you could really be sort of measuring testing capacity versus just like locations. It also doesn't tell you if the absolute level of access is good. So what the tool does is it compares sort of relative access across neighborhoods and groups, but it doesn't, pass any judgment on whether that level of access is good or bad. So it could be that there's really equal access across communities, but it's equally poor access across communities. So the number of clinics per 1,000 people is just, not sufficient, but it's pretty equal across all the communities of DC. And so, that would show up as equitable on the tool, but of course that's not meeting our sort of absolute standard of service provision that we would want to strive for. And then finally, the question of sort of whether data points are equally accessible within the geography. So this again gets to this idea of sort of more sophisticated ways of thinking about whether somebody has access to a resource. So for example, some of these clinics maybe are accessible via public transit while others aren't. So for transit dependent residents, their ability to access different testing sites will really differ based on how close they are to transit. And so that's something that's just not reflected in the current tool. Next slide. Awesome. All right. Well, before we move into sort of our discussion, we want to hear from you about sort of how you might think about using this tool. We just want to take a pause and open the floor to any questions or feedback.
Hi, this is Sonia in Charleston, South Carolina. We are excited to look at the tool. I was wondering about the county data. I know you said for cities, it's more than 50,000. Is there such a limit for counties, or does it look different?
Yeah, I don't believe so. So yeah, I can look at any county in the US.
Because I know like a lot of our cities aren't going to meet that that max minimum, I guess. Thank you.
Yeah, great question. Any other questions?
Hi, this is Rochelle from Miami, Florida. I know that we serve a lot of advocacy for COVID-19. I think this would be a great tool to let companies know where to have access to mobile clinics. I know there's a lot of them opening up that kind of access to for people who lack transportation, underserved communities who can't get to clinics, hospitals, or those kinds of things. So I think this would be a great tool for down here for when the mobile clinics need to know where is the best place to visit and administer COVID-19 vaccines.
Awesome. Thanks, Rochelle. It's great to hear.
Good afternoon. I might have missed this, and my apologies if this is duplication. How can we access this tool?
Oh, what a great question. I will put the link in the chat right now, unless Gabe beats me to it.
No, I think Elena, you're there. But yeah, just
All
to
right.
follow up, it is open source. So if you just go online to our website, you're welcome to use it, and we would love you to.
Thank you.
Is the latitude and longitude automatically showing up in these locations that we might be looking for things, or how do we necessarily have that or find that?
That's a great question. So there's a couple things that go on. One is that like just the data you need needs to be kind of spatial data that has some component of latitude or longitude to be able to put it in the tool. That's the only type of data the tool can handle. The tool itself, it gives you the option to select which columns are latitude and longitude. So it takes a guess. So like it guessed right, where it's like, hey, we think X, is associated with, I think it's X is associated with longitude and Y is associated with latitude. But suppose you didn't have as an intuitive of a name, you could just choose in the dropdown which variable it is. So I can just share my screen again really quickly. Like this is just the screen again, once I've uploaded this file that I just downloaded on the demo. And then these are all the columns in the data set. It guessed X, but maybe if you didn't, you didn't know or it didn't guess right, you could just put it in yourself. Is that helpful, or do you want to follow up on that?
Yes, if I'm looking for, let's say if I'm looking for proximity to parks, for example, and I go on whatever website to find parks in a particular city or county, if it gives me a list, should I just assume that latitude and longitude are there, or?
Yeah. Sorry, go ahead. My bad.
No, I was just, I'm just still confused how that comes about. If there are just certain places I can look for information about things like latitude and longitude, or, you know, do I have to go to Google Maps, for example, or Google Earth or something?
Yeah, that's a great question. And so I have two thoughts, and then Elena, definitely welcome your thoughts too. But one is that open data portals will probably be explicit about the types of data they have. So anytime if you go to a data portal and you see data that's like this, where it's like visualized as point spatial data, that it should either give you the latitude or longitude, or it should be very, very doable to get it from the data that they give you. Like, for example, they may give you a column with latitude and longitude in one column, and then you would just need to kind of separate those one column into two. So ideally, kind of the workflow would be to find data that has that available. And at least in my experience, these data portals across the country have good amounts of data. And the second thing is, there are different types of spatial data that aren't points. So the kind of other very common is called kind of, polygon. It's vector polygon spatial data. So it's basically just kind of shapes. So if you think about kind of like a map or a very common map that's like this would be, it shows all the states and it shows different colors in the states. Those aren't points, obviously, they're shapes. So we'll talk a little bit more about kind of what to do with that type of data in a couple slides, but there are ways to handle it so that the tool could work with it.
Okay, thank you.
This is Angie with Asian Media Access and Chinese American Chamber of Commerce. We are serving a lot of Asian Americans in our communities, and we definitely have a lot of data when we do the grantee report back into the central database. We just has an address and has our date and has the vaccines number. We are wondering, is that possible to compare with the data set to see if it's matching with the high numbers residents in that area for Asian American communities?
Yeah, that's a great question. And I think maybe this connects a little bit to Lyndon's question earlier. So I think you were saying you have addresses in your data, and that would be sort of like the geographic information that you have in your data. And so there would just be sort of one additional step that would be needed to go from address to that like latitude and longitude that can be mapped. The good news is there are a bunch of free tools for doing exactly that. And we can actually, I think we link later in the presentation to a resource that the Urban Institute put together. That process is called geocoding, going from an address to like a point on a map. And so Urban put together a blog post sort of comparing some of these different tools, and a number of them are free. So we'll definitely make sure that that's a resource, that's useful. And then I saw Sonia's comment about, get longitude and get latitude in Excel. So it seems like there could be some built-in capability in Excel too. So we definitely recognize that is, I would say, the key challenge for working with this tool is sort of getting your data into the right format. Once you have that, you saw how easy it was for Gabe just to drop it into the tool and then hit run. So, really, I think much of the work is figuring out what data you have and, getting it into the right format. And so I definitely can send some resources, and then also that's, something that's feedback that we would love to hear from you all. If you're saying like, oh, I would love to use the tool, but it'd be really great if I had some sort of resource or some sort of way to help, get this data ready to use in the tool. We're always thinking about what are new ways that we can support users of the tool. So that's really helpful feedback for us to hear.
Thanks.
Let's see, we were originally planning on sort of going into breakout rooms to have a discussion of how folks were thinking about using the data, or using the tool, excuse me. But I feel like that's what we've heard from you all in this sort of question and answer session. So I might say, for the sake of time, we'll put out one more call for sort of thoughts or ideas of how folks might use this tool or questions you have. And then maybe we could just sort of skip that first breakout and go into the rest of the presentation. So any other sort of questions or ideas you have of thinking how you might use this tool in your own work? Again, I might ask you to, we'll have another chance at the end for more sort of conversation and questions. So I'll ask Gabe for you to reshare your screen. Thank you very much.
Okay. We're in, can I get a thumbs up that you can see the screen? Okay, perfect. Thank you, Elena. Excellent. Okay, so here are the discussion questions that we mentioned that we're going to go forward. This is kind of this next section we were talking about that dovetails perfectly with the conversation we've just been having about the challenges to using the tool. So these are kind of the three big challenges we see, and that we've to some extent discussed. First, you need access to the geographic point data. So this is like a very legitimate question. If you don't have point data to analyze, it's going to be a challenge to use the tool. And then you may need technical capacity to download and or create, to reshape spatial data of other forms or different data to make it of this form. And then lastly, kind of on a different note, you're going to need context to understand why over and underrepresentation exists and how to address it. And I think that's, some of the skills that y'all are very well equipped to bring to kind of the applications that you'll be using the tool for. So kind of talking a little bit in more detail about each of these. So there's this first issue of access. And as we've said, the main prerequisite is you have to have point level data sets with a latitude and a longitude column. So that, and as we said, there are, city data portals have this. Also, many data sets that cities and counties have this data built in. So that's great, but it's definitely a challenge if you don't. But kind of this is just as what we talked about. If you have addresses, or also if you have census tract data, you're halfway there, and we can give you some suggestions on what to do. So that kind of moves very nicely into the second challenge of technical capacity. So the things we just mentioned, hey, suppose you have some spatial data, but it's not in this latitude longitude format. So what do you do? And as Elena said, there's this process referred to as geocoding, where you take an address as an input, you give it to some computer, machine, program, and then it will return to you the latitude and longitude for that point. And very excited about moving forward. Okay, and we have this data at Urban blog post that one of our former colleagues wrote that's exceptionally detailed in describing this process, and it's really helpful. So that's a really good resource there. It's also open, not behind a paywall or anything. Also, if you have census tract data, so that's a census tract is a census designated geography that has about 4,000 people. It ranges between about 1,008 and 8,000 at the very edges, but kind of it's in an easy way. I think about census tracts are like neighborhoods, kind of a big neighborhood that you could live in. So if you have census tract data, which is very common kind of scale of data to have, you can get the centroid of the tract to use as latitude and longitude. And centroid is another word for just a point that is in the middle of the tract. One way to do this, and actually a really helpful resource in general for working with spatial data, is this Missouri Census Data Center GeoCore. I think it's Geographic Correspondence Engine is what GeoCore, I believe, stands for. It's also open data, and you can use it to get centroids, among other things. So that's a really helpful tool if you're working with kind of spatial data, but that's not exactly of the form we require for the tool. So that's kind of the second obstacle. And then the third one is context. And this is, again, kind of a different, but really, really important challenge. So this is a key question kind of Elena has raised, and the tool is really not able to answer this question for you. This is a question you're going to have to think about and answer yourself. But why are there disparities in your data? You know, once the tool shows you that there's disparities, you have to think about what are the driving forces for that. And so some reasons could be the following with, for example, data collection issues. So it could be that just in the process of, you know, acquiring the data, something went wrong. So for example, I don't know this to be the case, but perhaps DC made an error and left off a point from the data set, you know, then it wouldn't show up and there would be more of a disparity, even though in reality, it's not the case. There could also be program implementation issues. So potentially a policy could have rolled out saying, hey, we're going to be really equitable in our distribution using some metric, but then something went wrong in that process. There could also be kind of, you know, maybe the tool and the data are perfect, and, you know, the tool has just shown, hey, there's historical inequities in our resource allocation system for many reasons. You know, obviously we all know there's issues of structural racism and inequality in cities in particular, and the tool could reflect that. And that could be a driving force why the data that you're looking at has these inequities. And then the last potential example that we just want to reference is a mismatched baseline data set. So this is exactly like the example Elena gave, where we're saying, hey, you know, we have some comparison groups on the tool, but maybe it would be helpful if we knew about, you know, other ones. So the example would be potentially COVID cases, or for the number of people who've gotten COVID, it might be a relevant baseline comparison data set that is not in the tool. So those are some of the obstacles we view. Yes, okay, so here's the next note. So the tool is kind of definitely not, you know, a panacea end all be all. It is kind of one part of what we would hope to be a larger decision-making processes that include, you know, non-exactly like quantitative data, but really important lived experiences and community input about their neighborhoods and surroundings. And we would just note that this is helpful, and we would hope it could encourage community engagement. You know, so we say here, you could use it to understand community priorities, collaborate to design strategy, and you could also hopefully help use it in creating an environment where everybody could feel comfortable sharing. So with this, like, for example, data walks. So those are some other notes in terms of context. Lastly, we've referenced this a couple times, but want to be more explicit about potential things we're thinking about that are not yet in the tool, but we hope could be at some point. So the first one is incorporating different measures of accessibility. So as Elena said, we're just counting, you know, in the census tract, you have access if you're in the census tract, and the point is also in the census tract. And that's a very reasonable definition, but it's definitely not all encompassing. Everybody goes outside their neighborhood very, very frequently. So we might also incorporate measures of like the distance to nearest, or how long it takes to travel to resources, and use that as a different way to compare access. So that's this first point. The second one, as we've said, you know, there's different geographic scales that we could incorporate, you know, region or metro area scales for analysis. The next one is incorporate additional baseline data sets. But this is definitely exciting. As we say with our last point, coming up later this year is a public API. So the way the code works right now, we go to the website and you give the website data, and then on the back end, it, you know, crunches the numbers, and then it returns to you the data and the visuals. But what we're working to build right now is a different way to interact with that back end that crunches the numbers. And what it will soon be able to do, we're hopeful for this summer as a targeted release date for this feature, is that you can interact with that backend through a programming language and code, where you just say, hey, here are the data sets I want you to analyze, and it will return to you those data sets. And if that's the case, you will be able to incorporate additional baseline data sets. So for example, where we compare to population age 65 and above, you could upload your own data set to compare to exactly the group you're interested in. So we recognize that's an area for future work, but the future work is ongoing. So stay tuned on that front. Okay. So lastly, we have this kind of maybe second set of discussion questions. I know we're a little bit low on time, but we're interested in hearing your thoughts on these as well. If you have any thoughts, we're very excited to hear them.
Thank you. This is Sonia with Charleston, South Carolina again. We're really excited about it. It looks great. I know that you showed us what it looks like with the map and the sliding comparison.
Mhm.
Does it come out in different report formats too, or does it put it side by side? Does it, I don't know, what else?
Yeah, that's a great question. So I think one feature of the tool that Gabe didn't show, but is present, is you can actually download like an image of any of the graphs that we have in the tool, as well as a CSV of the actual data that's being displayed in the graph. So with the disparity scores that we're showing either in the map or in that chart. If you downloaded a PNG of that slider, you can almost just think of it as a screenshot. It's like it would be exactly what you're seeing when you hit download. So I guess you could, move the slider all the way over one way and then the other way and download it twice if you wanted to do the side by side.
Thanks.
All right, I think we have time for one more question and then we'll hand it back over to our organizers. Awesome. Well, maybe we can stop the share and send it back. The one last thing I'll say before handing it back is in these slides, which we'll make sure that you all have access to, we'll coordinate with the our organizing team. Gabe and my contact information is in there as well. So if you have any questions about the tool or want to brainstorm more about these different applications that you all have raised, which are really exciting in this conversation, please don't hesitate to reach out. We'd be happy to talk more. And with that, and then here are some useful links and our email addresses. So with that, we'll pass it back.
Thank you so much, Alina and Gabe, for this awesome presentation. I'm sure everyone has learned a lot from it. Just before we end, we just wanted to do a very brief satisfaction poll. These help us to organize our future events and also highlight our next event, which will be on March 22nd. Which will be the APHA abstracts co-working session. So people will come together and we'll work on abstracts together. But once again, the slides and recording will be available on our community website. So, which will again also have Gabe and Alina's emails if you need it. Thank you so much for attending today, and we'll see you at the next event.